So what we're going to be looking at for the next couple of days are the three-dimensional shapes of different molecules. And they have those three-dimensional shapes because of the number of bonds that they have or the things that they bond with. And that becomes important when you talk about more advanced chemistry, especially things like, if you were dealing with a pharmaceutical company and you wanted to develop a new drug. A lot of drugs work by bonding or binding with certain things in your body and either preventing something else from binding at that spot or causing some kind of reaction by binding at that spot. And if you can imagine a three-dimensional puzzle in your body, enzymes work this way too. If a molecule doesn't have the right shape, it won't bind to that other molecule or to that spot or receptor in your body. So shapes can be very, very important when you take advanced chemistry. We're just doing really basic stuff today. So there are 5 shapes that we'll learn, and you'll get to see these in your model kit lab that we'll do tomorrow. There are a few steps that you go through to figure out what a molecule's shape is going to be. And this works whether you've got a flat line structure kind of picture or whether you've got a three-dimensional model in your hand. If you don't have a three-dimensional model to use, you have to start by drawing the Lewis structure or the line structure. The second thing that you have to do, and this is, again, regardless of if you have a flat picture or a three-dimensional model, is count the number of bonds that you have. The third thing is to count the number of unshared pairs on the central atom. And you should remember from last time that an unshared pair is a pair of electrons that is not involved in making a bond. It's kind of like those extra electrons that you have to draw around the outside. So we're counting the unshared pairs on the central atom. That means only the one that's in the middle of your structure. Once you know those two pieces of information, the number of bonds and the number of unshared pairs, then you can determine the shape. As I said, we're going to learn 5 shapes. We'll do a couple of examples of those shapes, and then that'll be it for the notes today. We're going to start with the simplest of all of the shapes. Linear. What does the word linear mean? Line. So this is the structure where all of the atoms are in a line. Specifically, there are 2 atoms involved in a linear structure. And I've got like a computer-generated picture here. What you're going to use in your lab tomorrow is not computer generated. It looks like this. Like these. So this would be linear. How many bonds does this have? 1. Is there a central atom? No. So we don't really have to count unshared pairs with this shape because there is no atom that's in the center and there's only 1 bond. So anything that only has 1 bond is going to be linear. Shape number 2 has 2 different names that it goes by. It is either called bent or V-shaped. And when you look at the picture for this, there's a couple different things that we have in this picture. It's a little bit easier to see the shape when we just deal with a three-dimensional model. This is bent or V-shaped. Both of those, I think, make sense when you look at the shape. But what are these little rabbit ears up here?
I thought those were spooky ghosts.
Ghosts? Well, if you look at the shape, how many bonds do we have? Two. And then there's got to be a reason that those bonds are at an angle, that they're not linear. Something has to push those bonds down so that they're at an angle. Unshared pairs. If you have unshared pairs on your central atom, and then there's another pair of electrons in the bond, all the electrons have what charge? Negative. And if all the electrons have the same charge, what do like charges do? Repel. So if you have electrons that are in the bond, and you have electrons that are not involved in the bond, the unshared pairs, those unshared pairs on the central atom, because like charges repel, they can force those bonds to move down at an angle. And that's why these molecules end up being bent or V-shaped. There's two bonds, and there's two unshared pairs on the central atom. This is a picture of a water molecule, by the way. Same thing as the one that I'm holding up here. This is a water molecule. The shape of this water molecule gives rise to a lot of the interesting properties of water. Water has a really high surface tension. You know, you can balance things on top of the water sometimes, like a paper clip or a needle. Water will form kind of like a ring when it freezes because of its shape. That's why snowflakes have 6 points. That's why ice is less dense than water, because that ring leaves empty space in the middle. So the shape of the molecule can tell you a lot about its properties. And especially with water, it makes for some very interesting chemistry. Next one is called trigonal planar. What does the trigonal stand for? 3. Tri usually means 3. And how about the word planar? Think geometry. What is a plane in geometry? It's not the thing that flies. Nobody knows what the word plane means in geometry? A flat surface. Very good. Now, the model kits that we have don't really allow for making this shape very well. Partially because it's not a very common shape. There's only maybe 2 or 3 molecules, simple ones that I can think of that have this shape. But if I can kind of hold these together, and you can see the picture on the screen, a trigonal planar molecule kind of looks like this. It's flat. If you were to lay it on a surface, all of those molecules would be in the same plane or in the same flat surface. Trigonal planar occurs when you have 3 bonds and no unshared pairs. There's no unshared pairs to push these bonds down at weird angles, so they just spread out as far as they can, and they end up looking kind of like spokes on a wheel. Shape number 4 is called trigonal pyramid. So what would be different about this one? Yeah, it's not going to be flat anymore because pyramids aren't flat. Trigonal still means how many? 3. So we have 3 bonds. And we also have 1 unshared pair. That unshared pair on the central atom does the same thing to this shape that it did to the bent or the V-shaped one. Rather than having everything flat like the spokes on a wheel, that unshared pair repels the electrons in the bond and it pushes those bonds down at an angle. So what you end up with, instead of something that's flat, is something that has a little bit of height to it. It looks more like a tiny little pyramid than a plane or a flat wheel. So trigonal planar would be all flat. Trigonal pyramid has a little height. And we've got one more to do. Tetrahedral. What does tetra stand for? 4. So how many bonds do we have? 4. What column on the periodic table makes 4 bonds? You should be able to figure it out based on your dot structures. What starts with 4 valence electrons? Carbon. So the carbon family is going to make the tetrahedral compounds. This is what that would look like. Believe it or not, all of the angles on this molecule are even. They're all about 109 degrees. There are 4 bonds. There are no unshared pairs. This one's a little harder to draw by hand when you draw the 3-dimensional shape. Most people, when they draw it, kind of start with like a trigonal planar, almost start with a tripod. And then once you have your tripod, then you put one up from the top. And if you're trying to draw the 3-dimensional shape, that's about as close as you can get. So let's do some examples. Draw the line structure for FH. How many valence electrons does fluorine have? 7. How many does hydrogen have? 1. How many bonds are we going to make here? 1. Line structure would look like this. What shape is this? It is linear. There's only 1 bond here. There's no central atom. So there's no unshared pairs that we need to count. Let's do another one. CH4. What's going to be your central atom? Carbon, because it makes the most bonds. 4 bonds. Which really tells you what it is, even without looking for unshared pairs, because we only had one shape with 4 bonds. Here's what your line structure would look like. What shape was this one? Tetrahedral. Next one. I should have picked a harder example for this one. Draw your line structure. What shape is this? Bent or V-shaped. And now that you're able to tell what the shape actually is, you could reflect that in your dot structure. So if you wanted to draw a more correct dot structure, you would have the oxygen kind of up or at an angle to your hydrogens. And this is actually a more correct or a better representation of what the molecule actually looks like than what we have on the screen. Next one, NH3. This is ammonia, by the way. Ammonia. NH3 is ammonia. Yeah, famous for the smell that's in the cat litter box, and also the smell when you get your hair dyed a different color.
I didn't know that.
Has applications for agriculture, and it's anhydrous form. It is. Most nitrogen compounds tend to be because they have 3 bonds. They can store a lot of energy in those bonds. Here's what your line structure would look like. How many bonds do we have? How many unshared pairs? So what shape is this? Trigonal pyramid. 3 bonds, 1 unshared pair makes trigonal pyramid. You do have to have both words with those 2 shapes, the trigonal planar and the trigonal pyramid. One word without the other is not going to cut it on the test. We have one more thing to do today, and that is a little bit of prep work for tomorrow's lab. Is there one more?
That would be the trigonal planar because that's no under.
I don't have another one.
It
Just
says
you
right
cross it
there,
out.
pH.
Oh, that's your trigonal planar one.
Don't give me this stuff, man.
Because blue, you wouldn't have to take it.
Okay, I copied this lab a little bit differently. Also to make it easier for me while I grade it. The stuff that you're going to fill out is on the front and in the middle. The directions are actually on the back. I think once you get going on this lab, you'll find you don't really need the directions page all that much. What you're doing tomorrow is playing with these model kits.
Oh, right.
So you will not need goggles for this lab. All of these colored spheres have holes in them. There are little sticks to represent the bonds. As you are putting these together and taking them apart, please be gentle with these. They do have the potential to get stuck. If you push too hard, I would prefer that that not happen. So do not beat them to smithereens, I guess. What we're going to do today,
All battle each other.
yeah, what we're going to do today is fill out this first chart. This first chart on the top is going to be kind of like your reference chart. So when you're putting all of your molecules together, you can look back at this chart if you need a little bit of help. The atoms that you're going to be working with are hydrogen, chlorine, oxygen, nitrogen, and carbon. So we need to figure out first how many valence electrons each of those atoms has. How many valence electrons does hydrogen have? One. If we were going to draw its dot structure, how many dots would we need? One. How many more electrons does it want to pick up or share? One more. Which means how many bonds does it make? One. That means you need a sphere with how many holes? One. Those are yellow. How many valence electrons does chlorine have? 7. So its dot structure would need 7 dots. Does it matter what side you put the single one on? No, whatever side is most convenient. How many more electrons does it want? 1. How many bonds does it make? 1. So the holes have to be 1. And these are green. Oxygen has how many valence electrons? 6. You need 6 dots for your dot structure. 2 pairs and 2 singles. They can go on whatever sides you need them to. How many more electrons does it need? 2. Which means it forms 2 bonds, which means it needs 2 holes, and these are red. Nitrogen, how many? 5. Draw its dot structure. 3 singles and 1 pair. How many electrons needed? 3. How many bonds? 3. How many holes? 3. These are blue. Last one is carbon. How many valence electrons? 4. Dot structure just has 4 singles. How many electrons needed? 4. Hopefully you're seeing there's a pattern here. 4 bonds, 4 holes, and these are black. If you take a quick look at the next chart, the next chart is about 2.5 pages long. You will be drawing dot structures, you'll be drawing the 3-dimensional shape, and you will be building the 3-dimensional shape. Some of them you have to name that shape. I need to see each of your models built before you move on too far. You will find that you have enough pieces, depending on the molecule, to build maybe 3 or 4 things. And I will be circulating around the room as quickly as possible to look at your models and check them off that you've built those things. I'll also check your dot structures, and I'll check your 3-dimensional pictures. So We will be kind of grading these as we go tomorrow, which is good news because by the time you turn them in, they should be perfect papers. But you do have to wait patiently for me to get around. We do have kind of a big group in here, and if you are shouting my name from the other side of the classroom, that is not going to make me come to your group any faster. So I will get around as quickly as I can to look at models and initial things and sign off on them.
Lucky us, please.
If you yell please, that is not going to help you. Nice try, but. So, bring these labs to class tomorrow, finish your worksheets for tomorrow if you have not done so already.
For tomorrow?
Yeah, the two from yesterday. There should be extras in the basket. And since we have a little bit of time, and Alyssa's not here, I will pass back your tests. You can take a look at those.